Hello everyone, welcome to this video. In this video, we shall be learning about how to calculate the sum of first n natural numbers and exactly what it is. So, in the result here says that if we add all the first n natural numbers together, we would have the answer as n plus 1 divided by 2, right? If you take 7 natural numbers, so what would be its sum? It's just given by simply putting n is equal to 7. So we would have 7 plus 1 divided by 2, right? So how much it would be? It would be 7 into 8 divided by 2, right, which is 28. So you can actually see what is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, right? This is 6, 12, right? And then we have 9 here, 21 and 7, that is 28. So you see we have the same result in this particular case, right? So how can we clearly see? We have seen it through examples, the example that this result is true, but is it actually true for all the natural numbers? So let's see and give it a proof. So here, because you can see here this kind of series 1 plus 2 plus 3 up to n, that is nothing but an arithmetic series, right? So all the numbers could be written in this form, in this arithmetic progression, where what is the first term? The first term is a, the common difference is the first term is 1, right? The common difference, the difference between each consecutive term, that is also 1, and we know the formula for calculating the sum, that is given by n by 2, 2a plus n minus 1 times t. So we can substitute the value of a here and d here, and we can solve it further so that we would have n by 2 into n plus 1. This is what was this result, right? We also have another way to prove this result using induction. Let's see that quickly. We wanted to prove 1 plus 2 plus up to n, all these numbers, they sum up to n plus 1 by 2, right? So for induction, what do? We take 3 steps. In the first step, we prove that when we take n is equal to 1, in that case our result is true, right? We will prove this thing. In the second case, we assume for n is equal to k, we assume that our result is true. Here we prove it, right? And in the third case, what do? We take n is equal to k plus 1, and then we prove the result for n is equal to k plus 1. So let's do all of the 3 steps one by one. For n is equal to 1, when n is equal to 1, our left hand side would, when we go up to 1, what would be our left hand side? It would just be the number 1, right? And what would be your right hand side? It would be n plus 1 divided by 2. So it would be 1 plus 1 divided by 2. What is 1 plus 1? It is 2, right? So 1 into 2 divided by 2, it is equal to 1. So you see your left hand side and right hand side is equal, hence our first part is proved. For the second part, we assume that a result is true for n is equal to k. So, hence, when we take our result 1 plus 2 plus up to k, we would have k plus 1 divided by 2, right? So what do? We will prove the result for k plus 1. So for k plus 1, what we are required to prove, we will go 1 plus 2 plus so on up to k plus 1, right? And here on the right hand side, we wanted to prove that it is equal to k plus 1 plus 1, which is k plus 2 divided by 2. So we wanted to prove that this thing is equal to this thing. So this is what I have written over here. So let's take the left hand side first. Left hand side is this one. Now you see the first k terms is nothing but the sum of first k terms, and in the second part here we have assumed that the sum of first k terms is given by k plus 1 divided by 2. So let's substitute the value of this one as k plus 1 divided by 2, and this k plus 1 would be as such, correct? Now what we have to do? We have to solve this one. So you can take k plus 1 and k plus 1 common from both the terms. This is this one. So you are left with k by 2 plus 1, right? So k by 2 plus 1. So again here you can take the LCM. So this would become 2, and this 2 could be written here in the denominator. So you would have k plus 1, k plus 2, and this is what you wanted to prove: k plus 1, k plus 2 divided by 2. So this becomes your right hand side. Hence our result is also true when n is equal to k plus 1. Thus it is true for all the natural numbers by the principle of mathematical induction. And this is what we wanted to prove here. So I hope you understood this concept well. Well, that is it for this video. Thank you for watching.